Before condemning any component, you need to understand how module enable conditions work, what the ECU observes, and when DTCs truly point to a real fault. This lesson gives you clear strategies to use logic, scan data, and targeted testing to avoid unnecessary replacements. A DTC doesn't always mean a component has failed. The module must encounter the correct enable conditions to run the test that sets a code. If any input, system state, or prerequisite is missing, the code may be misleading or delayed in surfacing. Before any monitor or self-test runs, the module checks for specific enable conditions, such as engine speed, temperature, voltage, and more. Only if these are met does the test execute, and only then can you trust a DTC reflects the actual system state. Many ECUs check not just one signal, but the relationships between related sensors, like map versus MAF. Even if the code sets for one circuit, a second input or a physical limit test might gate the monitor from running. Knowing which values must agree helps you find the true root cause. Scan data only tells you what the ECU sees, and sometimes what it assumes. If an enable condition fails, the reported PID can reflect last known good data or even a default mode. Always compare module reported values to direct measurements and related sensor readings. Before you trust any trouble code, confirm the module actually had power, ground, and valid input signals during testing. Use a meter to check for reference voltage, grounded return, and correct signal swing at both the sensor and module pin. A missing feed can block monitor logic without setting obvious codes. Follow a logical path. First, review freeze frame and conditions when the code's set. Verify enable prerequisites, test signal, power, and ground under real load. Then, interpret scan data with context. Only after all gates are open should you consider the component itself as faulty. Never assume that a code is a verdict on a component. If you replace a sensor without verifying enable paths and monitor prerequisites, you may miss a circuit, module, or condition issue, leading to a repeat failure and wasted effort. Every diagnostic path should start with confirming module enable conditions and matching data. This ensures that your tests, scan data, and replacements are based on real proof, not an assumption. Always begin your diagnosis with confirmable enable conditions before jumping to conclusions about component failure. This approach prevents costly mistakes.